All right, welcome to today's colloquium. It's my pleasure to introduce to you Matthias Perdekamp from the University of Illinois, Urbana-Champaign. Dr. Grosse is an experimental nuclear physicist, and so he's actually worked on an astonishing array of experiments when I looked at it earlier. So T-2 Fermilab, I think the original T-2 at Brookhaven, that's right. Bell, Phoenix at Brookhaven, now Atlas and Compass at CERN, and I think a few more. Yes, of course, there's work on Phoenix and the new electron-ion collider, the detectors that are being built from scratch now for that. At a, there's sort of another side to him, and that is this one. He's interested in threat reduction, threat nuclear weapons, arms control. And that's what you're going to hear about today. And I don't know if you're including some information about how that came to pass. But I think one of the ideas is that to engage physicists sort of in this topic that I think over the past decades, a lot of physicists have disengaged from this, even though they're sort of the original purpose. Well, we'll hear all about that. So welcome, Dr. Grosse, and actually as a token of appreciation, I have a little gift for you. So maybe we switch this out. You take the microphone. You can use it or
All right, thank you very much. Thanks for the kind invitation and introduction. I'm actually here on behalf of the APS Coalition of Physicists against the nuclear threat. I will tell you a little more through the talk what this is about. It's an attempt by the American Physical Society to gather support from scientists, both professional scientists and students, also engineers, in engaging with Congress to reduce the nuclear threat, the risks that evolve from having large nuclear arsenals. So one thing I should start with is saying that the views expressed are the speakers and not the coalitions. Please also notice that the speaker is a physicist and not a political scientist. But the nature of the subject matter is that we have to also talk about policy-related issues. In speaking about the Iran nuclear deal, I will start with a brief summary what the deal is about and where it is at the present time. I will discuss properties of arms control in general. I will describe the particular risks that arise from nuclear arsenals as compared to conventional weapons. And then I will go through the history of the Iran nuclear deal, the Joint Comprehensive Plan of Action, and discuss where it is today. So I also will comment on the responsibility of physicists every once in a while as we will go through this talk. And I want to start by looking at the secretaries of state and foreign ministers that gathered here for a photograph after the Iran nuclear deal has been signed. And you notice there are two of our colleagues. There's Dr. Ernest Muniz, a physicist who was the department head at MIT and was the DOE secretary at the time and coordinated the science and engineering input that was necessary as a basis to the Iran nuclear deal. And then you see here Dr. Ali Akbar Salehi, who was the director of the Iranian Atomic Energy Commission at the time. He played the same role on the Iranian side. He's an MIT-trained nuclear engineer. And then I think we might ask naturally, in order to make contributions to society as a scientist, do you have to rise to this level of recognition and expertise and responsibility? And I think I want to advertise that this is not necessary. Advance the slides. So I want to advertise one possibility how you can make significant contributions as a scientist, as a student. This year is a recent APS study on missile defense that was published in February. It was led by my colleague, Frederick Lamb at the University of Illinois. But I want to particularly highlight the contribution of my graduate student, Arik Tate, who is not really an arms control expert, but he is an exceptionally strong student in experimental high energy physics. He works on the Atlas experiment, and he supported this effort both through his computing and simulation skills, as well as through his writing skills. He is a TA in my advanced composition course on nuclear weapons, and he made major contributions. So the APS, Coalition Against the Nuclear Threat, has fellowships for students, for postdocs, for faculty, where you can team up with experts in arms control and work on arms control related issues. Then Arik got much more out of this than he was asking for. I don't know how many of you noticed this. A couple of weeks ago, there was an article in the New York Times where two physicists pointed out that there were errors in the evaluation of possible missile defense against launches of rockets in the boost phase. So the writing team, the analysis team acknowledges that there were errors. They're presently working on an erratum. The Coalition Against the Nuclear Threat now offers an opportunity for all of us to contribute to nuclear threat reduction. The QR code here will lead you to a page that is a sign up to the APS coalition. Presently, more than 800 physicists have signed up. And what the coalition will do is contact its members, perhaps monthly, perhaps every 6 weeks, with a request for support. And the support typically consists out of letter writing campaigns. And of course, there will be sample letters provided. And with little work, it will be possible to contribute making this coalition a success in its attempt to lobby for increased nuclear security. So I think the topic of the talk, the Iran nuclear deal, is also very contemporary and has a close connection with the war that's going on in the Ukraine. Why is there a close connection? Well, we have to look at the history of this conflict. It starts with the decay of the Soviet Union, which had a vast nuclear arsenal. Ukraine inherited a significant fraction of this arsenal, more than 500,000 warheads, making it instantaneously the third most powerful nuclear military, ahead of China, ahead of the United Kingdom, ahead of France. There was a question what to do with this. So there were bilateral treaties between the United States and the Soviet Union with regards to strategic arsenals. And in the Lisbon Protocol, it was agreed that Russia would be the legal successor to the Soviet Union in these treaties, and that Russia would take over the existing nuclear arsenals in countries such as the Ukraine, Belarus, and Kazakhstan, who had inherited significant parts of the Soviet nuclear arsenal. Immediately at the time, it was pointed out in Ukraine, but also in the United States, that this comes with significant risks and uncertainties. These nuclear weapons are a deterrent against threats against the integrity of the Ukraine. So if ever again in the future there should be a Russian threat against Ukraine, the arsenal would not be available to deter this threat. It then was agreed that an additional treaty, which amounts to safety guarantees by nuclear powers, would keep Ukraine safe, and Belarus and Kazakhstan. So in the so-called Budapest Memorandum in 1994, the nuclear powers of Russia, the United States, the United Kingdom, and I think also China guaranteed the integrity of the Ukraine. And this is why Ukraine settled for giving up its nuclear arsenal. 20 years later, as we all know, Russia annexed Crimea in direct violation of this agreement, and the United States and the United Kingdom did not back up the Ukraine sufficiently to deter the Russian threat, also in direct violation of this agreement. So the recent escalation seems to be a logic next step with an all-out invasion of Russia into Ukraine. Why is this a problem of nuclear arms control? If we want to convince Iran or Pakistan or any other nuclear armed nations to surrender or reduce their nuclear arsenals, they will point to this. How can we trust security guarantees that have been given if they are not followed up on? So this situation in Ukraine has the potential of derailing the non-proliferation regime that is meant to contain the proliferation of nuclear weapons. So that's why I think this is very closely connected to what's going on in Ukraine. So now what is the Iran nuclear deal, the so-called Joint Comprehensive Plan of Action about? It's a deal between the P5+1 and Iran to stop the Iran nuclear program from further accumulating highly enriched uranium. Who are the P5+1? The P5 are the permanent members of the United Nations Security Council. These are the 5 original nuclear powers, the nuclear powers that were nuclear powers at the time of the signing of the Non-Proliferation Treaty. So this is the United States, this was the Soviet Union, now Russia, China, the United Kingdom, and France. +1 stands for the EU and Germany that were included for their economic might. Basically, I believe, to have additional handle to force Iran into a treaty. So the P5+1 want to make sure that Iran's nuclear program is reduced and placed under the supervision of the International Atomic Energy Agency, the agency that enforces for the United Nations the Non-Proliferation Treaty. And on the other side, Iran aimed at reducing the economic sanctions that were crippling, still crippling the economy of Iran. So to connect to our responsibility of scientists, one problem, if we look at something like the Iran nuclear deal, is pretty complex. The Iran nuclear deal is just under 150 pages of a very technical language that is actually difficult to understand if you don't have a broad background in political science and then also physics and engineering. And one big challenge for us is to communicate to the public and also to communicate to the political decision makers. One thing I want to point you to, if you want to form yourself opinion that's founded in detail on what's really in the Iran nuclear deal, rather than what's in the public media, I want to point you to this Congressional Research Service paper by Katzman and Kerr. This is only 40 pages or so, and it's really a very clear summary of the Iran nuclear deal. It is a contribution two scientists make. This is what the Congressional Research Service is for, to inform the public and political leadership of the information that's relevant in the context here of the Iran nuclear deal. Of course, the Congressional Research Service is much broader. They discuss any topic and analyze any topic that's relevant. And this you can use as a resource for yourself, for your students, and maybe also for contributions to the public discussion. So now, what is the problem with the Iran nuclear deal in the public discussion and also in the political discussion? I think most of the problems that we observe can be traced to two fundamentally different concepts of what the Iran nuclear deal should be about. Here's number one. The JCPOA is a nuclear arms control treaty, very narrowly aiming at avoiding that a complex conflict escalates into a nuclear exchange. This is actually modeled on nuclear arms control during the Cold War. Think of the START Treaty. Pick your favorite bilateral treaty between the Soviet Union and the United States. The only purpose of these treaties was to reduce the risk of nuclear conflict. In no way there was a possibility that a treaty like this would settle the broader conflict between the Soviet Union and the United States. That was just not part of the scope. In fact, it would be completely unrealistic to expect a treaty that could settle such a complex conflict. So the example to follow in this view of the JCPOA is the bilateral arms control over nuclear weapons during the Cold War. And I think I tried to illustrate this by showing here as a function of time, starting 1950, ending 2017, the arsenals both in Russia, formerly Soviet Union, the number of nuclear warheads is here in red. I don't know if you can see this at the peak, the Russian, time the Soviet Union had just under 40,000 warheads. The blue are the arsenals in the United States. And what we see here is that slowly, by patiently negotiating ever increasing in scope nuclear arms control treaties, trust was increased, and it eventually was possible to reduce the arsenals from a peak of about 70,000 warheads in the mid-80s to the about 17,000 that we have. And so, and this treaty is focused very narrowly on the nuclear threat. There was no discussion on the long list of grievances that existed between the East and the West. Oh, I'm not sure we know this openly. I think it is limited to the radiation damage to the electronics in the warhead and other components. And I don't think we know the time. One thing we do know is that there's a stewardship program to constantly replace and update the warheads. And then with regards to the fissile material, the half-lives are such that it's not relevant compared to the lifetime of our society. Lifetimes are long, and if the United States goes like all other large powers have evolved, I think there will be someone succeeding us before the fissile material needs to be exchanged. So then there is another view. And I show here Prime Minister Netanyahu at a speech to the United Nations in 2012, who warns against Iran nuclear deal. And it is very understandable because Iran has a fairly aggressive political agenda in the Middle East. And Israel takes the view that this contract should address a broader range of grievances. It's not narrowly a treaty to reduce nuclear threat. It is a treaty to reduce or resolve the threat that arises from Iran's political ambitions. And there are really significant grievances such as Iran's support for various terrorist organizations, be it in Lebanon, be it in Yemen, be it in Iraq. So now the deal was severely affected by how this panned out in history. The deal was signed and started to be implemented during the Obama administration. Then in the Trump administration, the view that we heard second became the dominating view. It was formulated clearly by Secretary of State Pompeo, who demanded additional 12 points that Iran had to comply with if the United States was to stay in the deal. And I think these are very reasonable demands. For example, stop supporting Hezbollah, stop supporting the Shia militias, stop supporting terror organizations in Yemen. I think you probably all follow the war in Yemen, really terrible. Regardless of what you think, who is at fault, it seems very reasonable to demand that this should be not supported on all sides. The only problem with this is that this is demanding a complete change of Iran's political agenda. It's a little bit like going to a START treaty negotiation and tell the Soviet Union, oh, and please, by the way, take down the wall in Berlin and free Budapest, and let us openly trade. It's just not possible to accept this on the other side. And of course, this was clearly also understood on the United States side. And as a consequence, Iran was not able to meet this additional demands. And the United States removed itself from the agreement. And then in the aftermath, Iran stepwise removed itself from this agreement as well. So now let's talk about arms control in general. And I want to use the Chemical Weapons Convention to point out a few principal difficulties that arms control faces. Namely, that it's an extremely tedious process that is generational, meaning it stretches over several generations if it comes eventually to a success. It has many enemies, and it's very difficult to succeed. When in World War I, chemical weapons were used, more than 190,000 tons and 100,000 soldiers or so were killed. People were horrified and immediately agreed that something ought to be done, resulting in the Geneva Convention from 1925. But it turns out that it would take another 70 years before there was a solid arms control treaty, solid meaning there is a convention and an organization that can enforce the convention that calls for the abundance of, not the abundance, abandoning chemical weapons. So this is the Chemical Weapons Convention that entered into force in 1997 and that bans and uses the possession of chemical weapons. To give you one example for the kind of difficulties that you always have, in the convention, everyone agreed to get rid of their chemical weapons by 2012, including the United States and Russia, with the two largest arsenals. However, it turned out technically to be more challenging than anticipated. And even today, the United States has not destroyed its entire arsenal. So I think it's now expected that the United States will reach this goal in 2023. And if I haven't made it clear enough, it's not that the US acted in bad faith. It really worked towards the elimination of this chemical arsenal. It just turned out to be more challenging than the United States was prepared to meet. Then this convention is criticized on all sides. So for example, when Syria, that had not joined the convention, used chemical weapons against its own citizens, it was widely criticized and was seen as an example that arms control is bound to fail and that only strength is sufficient to stop an adversary from being a bad actor. On the other hand, also many people see it as a positive thing. When the Organization for the Prohibition of Chemical Weapons helped with its infrastructure to collect chemical weapons from Syria and to destroy them, more than 98% of chemical weapons in Syria were destroyed, still allowing the Syrian government to attack with the remaining 2% its own citizens. But this is still a big success. It's just imperfect. This is an important component in arms control. If you have a deal that reduces the nuclear risk, you should not expect that it solves all the other problems that we're having. This just has not happened historically in arms control. So all in all, this was seen as a big success. And the OPCW won the Peace Nobel Prize for the role it played in reducing the chemical arsenal. So now for nuclear weapons, the threat is unlike larger compared to chemical weapons. This is an image I'm sure many of you have seen. It shows parts of Hiroshima, or better, where Hiroshima used to be, after the nuclear attack in 1945, at the end of the World War II. 75,000 people were killed immediately, 70,000 were injured, and many of whom died in the weeks following the initial attack. This was a weapon with an explosive yield equivalent to 15,000 tons of TNT. Today's weapons are unlike larger. The thermonuclear weapons that sit at the top of the ballistic missiles measure in hundreds of kilotons. Typical size of the US weapon is between half a megaton and a full megaton. So think roughly 60 times what we saw in Hiroshima, and there are hundreds of such weapons. And so it turns out that nuclear weapons really are the only weapons in our arsenal that instantaneously can kill hundreds of thousands of people and erase an entire city, even a large metropolitan area. Think of Houston or Dallas here in Texas. And nothing can be done preparing for this attack to somehow reduce the impact of the weapon explosion. And nothing can be done to deal efficiently with the aftermath. In particular, if the attack is part of an all-out nuclear war that also will destroy neighboring metropolitan areas. So let's go over some of the details that might happen in a nuclear attack. I assume a thermonuclear weapon with 1 million tons of TNT and explosive power. We assume an airburst. This is the most efficient mode of attack if you go at a metropolitan area. Rather than exploding this at the ground, it's better to allow the fireball and the pressure wave to expand freely in the atmosphere to distribute over a large area on the surface, just as it was done in Hiroshima and Nagasaki. So the height of burst is 1.4 miles for a 1 megaton thermonuclear device. And then here is the impact on metropolitan area as function of distance from ground zero in miles. I don't want to look at this in too great detail, but let's stop here at 4 miles. And we notice that the pressure wave still has 5 psi. That's enough to take down any residential housing. It actually severely damages most commercial housing, even if it's steel and concrete. The combination of pressure wave and thermal radiation is particularly devastating. Think of a gas station somewhere in Dallas, maybe here. So first comes a heat wave. Everything is extremely hot. Then comes a pressure wave that opens whatever fuel tanks they have, or trucks with their fuel tanks, and everything will be on fire. So it's chopping wood. This is what the pressure wave does, and then it's ignited. So if this happens in most of the metropolitan areas, the Russian side is something like up to 1,000 weapons like this run per trigger alert, that trigger alert, and can be launched within a few minutes after a presidential order. Now then the whole infrastructure, civilian infrastructure in the United States would break down. In Hiroshima, days later, rescue personnel arrived from nearby cities. Nothing such would occur in an all-out nuclear war. The whole social fabric is gone, be it transport, healthcare, agriculture, or political decision processes. Further, the fallout will force the evacuation of vast areas, even far away from the areas that are being attacked. And then one detail that is often not appreciated is nuclear winter. What is nuclear winter? If we have a large aerial fire like this, it either remains a conflagration or a firestorm. This will transport massive amounts of soot into the atmosphere. It will distribute around the world and cool down the temperature in the atmosphere for many years to come to temperatures where agriculture will stop. So I'm not sure to what extent you're familiar with this, but one thing I observed in the classes that I teach non-science majors is that this one in particular, the nuclear winter, are not known. I think people do not know the scale at which there are fatalities in the immediate attack, which on all out nuclear war are estimated to be between 50 to 150 million people in this country. And so the question again is, with regards to the responsibility of scientists, do we, who can read about this, process it intellectually and understand it, do we translate this to people in the general public and also to our political leaders? Here's a simulation from Alan Robock. He's a climate scientist in the APS Coalition Against Nuclear Threat. What this shows is the aftermath of a war between India and Pakistan, in which each of the countries uses 50 weapons of 50 kilotons each, Hiroshima-style weapon, largely on metropolitan areas. And what you see there is how the soot on the left is first transported up into the atmosphere, and it goes well up above where it rains out. And then here on the right, you see how it distributes around the world. The scale here tells you what fraction of the solar radiation is blocked from reaching the surface of the Earth. And it turns out in this simulation that this would lead to food insecurity already in such a limited scale nuclear war, limited compared to the size of the arsenals in the United States and Russia, in many countries in the developing world. In the United States, we would be fine. Our growing seasons in the Midwest are long enough. If our growing seasons are cut by 10%, we still will have a safe food supply, but that's not the case in many countries around the world. So I think this kind of information largely is not discussed in the media and not relayed in schools or during congressional visits that physicists may make. Mostly talk about funding, but I think it's important. Here's another example. This, for a particular war scenario and for a particular wind pattern, are projections from FEMA, how the fallout patterns would look across the United States. Let me explain first that some of the targets in an all-out nuclear war between Russia and the United States would be nuclear installations. For example, here in the Northwest, these are the Minuteman III silos. There are about 400. It's kind of thought that Russia will attack each of the silos with 2 megaton type weapons, giving them a fair chance to eliminate them. They're heavily fortified. Even a megaton warhead has to land somewhere within 150 meters to destroy them. Now, what does this do? Well, it digs out quite literally this fortified, strengthened silo, and it propels an enormous amount of dirt into the atmosphere. This dirt will travel in the atmosphere. Attached to it will be radioactive debris from the nuclear explosion. And the radiation levels that result from this downwind, as this rains out, are so high that the regions in yellow and dark orange certainly would have been to evacuate. So I'm from here, I think. So actually, all of Illinois, more or less, at least the north, had to be evacuated. Actually, much of the Midwest and also the East had to be evacuated. So the interesting question is, why are the American nuclear assets stationed where they are? Was there someone who really was worried if we could survive a nuclear war? Well, certainly not. it's someone who I think did not know about this. The things are stationed where they're stationed because congressional delegations were very eager to get funds to their rural, economically poorly developed areas. It's great for the Dakotas if they have a military installation that creates jobs. Oh, it doesn't make a difference. It goes over the pole. You also could put it in Maine. If you as a scientist would have talked to our political leadership, maybe it would have ended up in Maine, and the fallout would go under most weather conditions. So the distance to Russia is roughly the same as it goes north across Canada. So I think there's just another example where the scientific community failed to communicate to the public and to our decision makers. And one thing that's my personal opinion, it's actually not enough to communicate to political decision makers. Now, if you're here in the region, the rural Northwest, the public actually will demand from their political leaders that they get these funds to Wyoming or to North Dakota. And you have to educate them as well. I think politicians are subject to public pressure. And if there are significant economic reasons for a decision like this, I think you need a two-pronged approach in educating both the public and political leadership. And I have my doubts that this really took place. So now, of course, our political leadership knows about this threat, and people have worked hard to have a mechanism in place that tries to prevent such war from happening. So what the United States has, and similarly Russia or the United Kingdom or France, is a nuclear force that can survive the first strike and then guarantee destruction for the adversary. So this is mutually assured destruction. The United States, this is a triad with naval forces, with Air Force, and also land-based missiles. So this should work if we have rational actors. No rational actors will ever initiate a nuclear war. The only problem is we need to require that this is 100% fail-safe against technical malfunction, against human error, or malicious acts. And I think there are many experimentalists here who is running an experiment that doesn't fail. If you step in your car, you know that you have a finite risk that you will be in a fatal accident. If you go on a plane, same thing. If you operate a nuclear power plant, there may be a major accident. In history, there has been no technical system that was 100% fail-safe. Again, this is not a new discovery. John F. Kennedy pointed this problem out in his speech to the United Nations in the early 60s. He said, today, every inhabitant of this planet must contemplate the day when this planet may no longer be habitable. Every man, woman, and child lives under a nuclear sword of Damocles, hanging by the slenderest of threads, capable of being cut at any moment by accident or miscalculation or by madness. The weapons of war must be abolished before they abolish us. Let's look at some examples that refer to possibilities of accident and maybe madness. First, I want to introduce you to Lieutenant Colonel Stanislav Petrov. He was a lieutenant colonel in the Soviet early launch detection center just outside Moscow, when one night the launch of 5 American ballistic missiles was detected. It would have been his duty to pass along this information to the presidential leadership of the Soviet Union. And it is widely thought that this would have set into motion an automatic response to this missile launch that could have resulted in a full nuclear exchange between the United States and the Soviet Union. Luckily for us, Stanislav Petrov was directly involved in the commissioning of the system and had his own grievances about the readiness of the system, and had actually an inkling that there could be a failure mode that would make this detection incorrect. So against regulations, against orders, he decided to wait, and luckily was right. It did not help him with his personal fate. He was, of course, demoted for this, and he was fired. But it is an example how technical malfunction can lead to possibly a nuclear war. Here is another example. This has a little bit to do with having to guarantee that for all future nuclear materials and nuclear arsenals are safe. So let me introduce you to Sister Megan Rice. She is an American missionary who was a teacher in Africa for most of her life. When she came back to the United States as a Catholic nun, in her retirement, she turned into a nuclear activist. So in 2012, Sister Megan Rice, age 80, and two retired peace activists, Michael Bawley, Greg Bartlett-Obed, decided to break into the Y-12 nuclear facility at Oak Ridge. They made it all the way to a building with 400 tons of HU stored. And they were able to protest there, painting messages and singing peace songs for 20 minutes before security intervened. In this, they cut through 4 layers of security defense. And as much as I like Sister Megan Rice, if security at Oak Ridge would have worked, she should have not survived cutting through the first fence. Nuclear assets have to be guarded with lethal force. And this has to work perfectly at all times. Otherwise, we cannot be certain that this arsenal will fall into terrorist hands. And this is not one example. There are multiple examples like this, including, for example, nuclear-armed B-1 bombers that were not guarded on military installations because it was not known locally that they carried nuclear weapons. So the biggest question to me is this: if this can happen in the United States with all its wealth and all its might, what is going to happen in nuclear weapon states that don't have the same means to guard their arsenals? If the United States has a nuclear arsenal, it will induce an arsenal in Russia. If Russia has an arsenal, it will induce an arsenal in China. If China has an arsenal, so will India, so will have Pakistan. And nuclear security is only as strong as the weakest link in this chain. If the regime collapses in Pakistan, there's no good plan how to protect the nuclear arsenals. And one day they will show up in a terrorist attack on New York City or on Moscow or on London. This is a building that was taken in the Soviet Union right after the fall of the Soviet Union. This is a high flux reactor at the Khrushchev Institute that had easily enough HEU for one nuclear bomb. After the Soviet Union decayed, there were hundreds of sites that were not sufficiently guarded with nuclear technology and fissile materials. You also may want to think about this in context of the present war in Ukraine. One possible outcome is that Russia will destabilize again. Not being able to properly protect nuclear materials and technologies. That is a really concrete risk. We went through this already once in history. If you worked at one of the big national labs, like Brookhaven or Fermilab, or at CERN in Europe, or at DAISY in Germany, you may have noticed how many Russian scientists were invited to make sure that they are fed and paid and don't buy out or sell out to the Gaddafis and Hussein's of this world. This is a big problem. Nuclear arsenals induce arsenals elsewhere. And even, if we are able to protect ours, how can we ensure that others protect their own nuclear arsenals? So what's in place to keep the world safe is the Non-Proliferation Treaty that divides the world into nuclear weapon states, the 5 original nuclear weapon states, and everyone else who has a guarantee that they can use nuclear technologies for civilian purposes as long as they don't develop a nuclear weapons program. And this deal is implemented by the International Atomic Energy Agency, the IAEA, based in Vienna. This is one of the branches of the United Nations. They have safeguard agreements with all the non-nuclear weapon states. They frequently inspect these countries around the world, be it the Netherlands or Iran. This agreement is really pursued and implemented with extremely high priority. This is actually the reason why the P5 with adversaries such as Russia and the United States and China got together to somehow make sure that Iran remains a non-nuclear weapons state. Amazingly, even during the Ukraine war, Russia and the United States further collaborate on somehow preventing the proliferation of nuclear weapons to Iran. So this is a strong indication, if you think back to the beginning of the talk, with this conflict between these two models. Is it a nuclear arms agreement? Is it a wider agreement that addresses the Iran threat? Certainly the P5+1 and the international community see this as a nuclear arms agreement that is meant to uphold the NPT and to prevent the proliferation of nuclear weapons to a 10th country. So now let's project possible consequences of the nuclear exchange between Israel and Iran on a concrete situation in Israel and Iran. Let's say Iran was to use a 150 kiloton weapon and exploded on Tel Aviv. What would be the consequence? Large parts of the nearby areas could not be inhabited for years to come. The immediate number of fatalities in this simple simulation that's available through the webpage of Stephen Institute for Technology, 250,000 people would die immediately. Another 300,000 are severely injured. Israel, we believe, has assured second strike capabilities. So if Israel was to strike back on a target near downtown in Tehran, some 850,000 people in the simulation would die immediately. 2.5 million would be injured, many of whom severely not to survive the weeks to come. So these are the consequences if the wider conflict between Israel and Iran ever should go nuclear. And the nuclear deal basically tries to not solve the conflict, but to prevent this nuclear component of it. So what is the history of this present situation? So Iran was a close ally of the United States in the 1960s and the 1970s, and through the NPT regime, acquired nuclear technology. The United States, for example, helped with the Tehran research reactor. There was a broad program to build up to 23 power reactors. The situation changed dramatically with the Iranian Revolution in 1979, in the aftermath of which the United States introduced ever more severe sanctions. And at some point, Iran started to enrich uranium beyond the immediate needs in the reactors it was running, such as the Tehran research reactor or the future heavy water reactor in Iraq. And the situation continued to escalate with ever more severe sanctions and enriching more and more material until Hassan Rouhani was elected president of Iran, and the Obama administration came to power in the United States. And there, both parties reached out to see if this couldn't be resolved through negotiations. And in this process, the P5+1 was formed. And as an initial step of creating a trust, the two sides agreed on what's called the JPA, the Joint Plan of Action, at the end of 2013. This was quickly implemented, and Iran met the stipulations of the JPA. Some technical preliminaries. There are two routes to nuclear weapons, and Iran has facilities to pursue both. One is uranium enrichment. So you have to enrich uranium-235 to more than 90% to have something that we call weapons-grade material. This is what's often discussed in the media with the ultracentrifuges that Iran has. And then, however, there's also an alternative way, a plutonium way, which is what's commonly used in the United States or Russia. And here in uranium reactors, you breed plutonium and then separate it out. The Iran nuclear deal has to address both of these pathways. Here's an example that shows the ultracentrifuges in Natanz with President Ahmadinejad at the time visiting. Iran had a large number of ultracentrifuges and had amassed almost 13 tons of uranium enriched to 20% uranium-235. The progression of this is shown in this plot. Red is the available 20% uranium. And then in green is the number of warheads that could be made from this if it was enriched further to 90%. So at the time of the Joint Plan of Action, Iran had enough uranium for 8 warheads or so. So then on the plutonium side, there's the Arak complex, which is a combination of heavy water reactor and a heavy water plant. The Arak reactor is a 40 megawatt water that does not use light water, but heavy water with a much better neutron economy. So you don't have to enrich uranium to the same high percentage to operate. And this is a good pathway to make plutonium. Iran nuclear deal seeks to address both of those pathways. Let's look at the Joint Plan of Action that was agreed upon in November 2013 as a first measure to build a trust. And what's shown here, I think, is a plot from the Balfour Center that the Arms Control Association shows that shows the implementation of this. So the agreement was made in November 2013. And by August 2014, no 20% enriched uranium was left in Iran. This also was confirmed by the IAEA in its quarterly report to the Board of Governors. There's a page that details out that Iran has stopped enriching uranium beyond 5%, that it has not operated the cascaded ultracentrifuges, and that it has diluted or exported all the 20% uranium. One thing that I think is worthwhile to point out, so this is an approach that follows classical models of arms control of patiently building trust and at all times doing the next step possible. There's another case where this was not attempted, where the approach taken was much more adversarial, namely the case of North Korea. And as you all know, North Korea now is the 9th nuclear weapon state. So this approach has failed. Perhaps there is a hope to do better in context of Iran. So what are the goals of the Joint Comprehensive Plan of Action? Actually, the main goal is to make Iran a regular member of the Non-Proliferation Treaty. Everything else in the Iran nuclear deal is temporary. It's a transition to make Iran into something like the Netherlands. The Netherlands has a nuclear industry. They enrich. They are regularly inspected by the IAEA. There are no signs of nuclear program. Part of this is very important that Iran also adopts the additional protocol of the NPT. In the early 90s, it was found that Iraq successfully evaded the IAEA inspections and managed to have a clandestine nuclear program that they later abandoned. And in response, new technology was introduced at the IAEA, which largely is extremely sensitive environmental testing. So the IAEA now tests the soil, the water, the air. If small traces of uranium or plutonium isotopes are found, they can, via the United Nations Security Council, demand access to any facility in the country within a very short period of warning. So this is thought to make the NPT as close to perfect as possible. And then, so this would make Iran into a regular NPT state. And in addition, Iran actually had agreed for 20 to 25 years to make available to the IAEA every single detail along the uranium supply chain. This is not normally demanded of a country that signed the NPT. This is something that was added for Iran. And then, of course, in the short term, in the interval of the 10 years that lead to the state where Iran is a regular member of the NPT, there are measures that cut short the two pathways that Iran may be seeking to nuclear weapons. Here are the measures with regards to Arak, the heavy water reactor. This is the plutonium pathway. And the deal basically says that Iran will destroy the reactor core of the detector, and that with the help of P5+1 countries, it will redesign the reactor into a reactor that is less suitable for plutonium production. Iran also agreed to permanently export all spent fuel from the Arak reactor to one of the P5 member states, basically closing the plutonium pathway for nuclear. Then, with regards to Natanz, it was agreed that Iran basically discontinues most of the operation of ultracentrifuges. What was left are the ultracentrifuges that are necessary to produce the limited amount of uranium enriched to 3.7% roughly that is necessary for the heavy water reactor. So this would cut off the uranium pathway for Natanz. And then similarly for Fordo, another site with ultracentrifuges, this would be converted into an international research facility with tough limitations on the number of centrifuges and also the number of research that could be carried out on centrifuge R&D. So that was the deal. We already discussed how the United States left the deal, and Iran then stepwise returned to again enrich uranium. One of the most serious consequences of the United States leaving the Iran nuclear deal is that Iran has blocked IAEA inspectors from being in Iran. I think at the height of the deal, there were 170 inspectors with really very sensitive instrumentation, largely developed in the United States. And the level of knowledge with regards to the Iranian facilities was very high. By now, we know very little. I think in the latest report that I have seen, the IAEA reported in March in its quarterly report that 33 kilograms have been enriched to 60% uranium-235. Never before had Iran enriched to more than 20%. It's estimated that the capacity of the ultracentrifuges is 4.5 kilograms per month of the 60% enriched uranium. So today we are somewhere at 180, at 60 kilograms, and at 180 kilograms of 20% enriched uranium if we extrapolate this. And so the breakout time has changed from about 2 to 3 months for Iran to create a nuclear weapons. At the time the nuclear deal was agreed upon, to just a few weeks. If Iran decides to go nuclear, we have unfortunately to expect that they would have a nuclear weapon within 2 or 3 years. All of the Iran nuclear deal, this is often misunderstood. It's not possible to totally eliminate a country from a pathway to build a nuclear weapon. This is actually the key quantity here, the breakout time. With the Iran nuclear deal in place, the breakout time was a year. It's also not perfect, but it's enough time for the P5+1 and other powers to work with the United Nations, for example, on organizing a military response. At the present time, we are blind. We don't know what they're doing. We do know that they could choose to have nuclear weapons sometime in November, easily. And so our options are much more limited. So the war in Ukraine plays a role in these negotiations that have been resumed by the Biden administration. It plays a big role that the United States pushes together with China and Russia. Of course, Russia now has some additional interest, namely to gain some economic trade. Russia now sees the Iran nuclear deal as a tool with which they could benefit economically. So, for example, if Iran exports spent fuel, this should be then sent and be processed in Russia. The present situation is that the European Union has provided a new draft. They called it their final draft. It was circulated August 15th to Iran and to the United States. Both the Iran and the United States have responded. I think there are 2 sticking points left. One is actually a demand from the IAEA to investigate sites, nuclear sites in Iran that Iran has not properly declared in the past. And IAEA has complete questions. And then the second is the demand by Iran that there should be guarantees of economic help in the case that the United States should withdraw again from the Iran nuclear deal, possibly after the next election. So this is where things are. On the United States side, there's an additional complication, the midterm elections in November. It is not clear if the Iran nuclear deal is a helpful topic to discuss in public prior to the midterm elections. So I think that the most likely scenario is that it will sit at least until the end of November. And I think the period of time where this is without monitoring, where Iran can make progress towards nuclear weapons without being detected, this time keeps increasing. And the window of a successful deal and preventing Iran from turning into a nuclear power may be over soon. So Iran may be the 10th nuclear power that it will be on the world stage. So I think I want to end by again inviting you to join this APS Physicists Coalition for Nuclear Threat Reduction. This QR code will lead you to a webpage where you can sign up if you choose to do so. And you would be joining 800 or more than 800 physicists who already have signed up. And perhaps I should repeat, this is open to all students and physicists and engineers, physical scientists. I think we could not be certain that they not already enriched enough, 90% HE, that could be. But there are certain steps, I think, in the assembly of nuclear weapons. For example, studying the boson, which I think we may be able to detect if they started experiments. And of course, they could make a very low-tech weapon, very similar to the approach the United States took. If they go for a gun-type weapon, testing may be not necessary. So they may be able to use that without us giving a chance of detecting. North Korea has nuclear weapons, I think. So I think this is a complicated question. So we know that North Korea has tested weapons. And I think that there were times, the way by design this is supposed to be prevented by the design of the NPT, the Non-Proliferation Treaty. The IAEA monitors for illicit activities in the country. They certainly did so in North Korea, and they informed the United Nations and actually all members in the NPT that there were such illicit activities in North Korea. So then the next step is, if the United Nations Security Council is informed, to agree on a pathway how to stop this. And this can be economic sanctions, which was agreed upon. This also can be military intervention. And that was not agreed upon. I think the reasons for this are multifold. One is the strategic location of North Korea, where in the United Nations Security Council, it may be difficult to get an agreement between China and the United States and Russia. I think another issue was simply domestic politics in the United States. Among one of the critical periods during the Clinton administration, the United States dealt with an internal scandal that took much of the attention. In Russia, I think they were dealing with the enormous economic challenges in the aftermath of the breakdown of the Soviet Union. And this is how North Korea was able to sneak by. But I predict similar dynamics is going on with Iran. One thing, if Iran chose to now move forward, that will prevent us from acting as the war in Ukraine. Maybe also the situation over Taiwan. And I think we might decide on a military strike against some of these facilities, Natanz or border. I think that will be of very limited duration. Iran is a country of 85 million people with really significant knowledge and infrastructure in their science and technology sector. To me, it's a little bit like Germany between World War I and World War II. If we don't engage with them, if we ostracize them and exclude them, they can decide for themselves in any direction they choose. Whatever stop we try through military action will be temporary. So the situation is very difficult, in my opinion. Yeah. So I don't think we know this for certainty, and Israel neither confirms nor denies. But if you look at most of the experts, what they publish, people think that Israel has somewhere between 80 and 200 warheads, but this is implying what is possible. One thing I find interesting, Iran has acquired submarines from Germany that are capable to provide second strike capability. Again, we don't know this for sure, but this investment makes the most sense if Israel really wants to build second strike capability and has some submarines at all times somewhere in the Eastern Mediterranean as basically a short second strike capability. So we couldn't say with certainty, but it appears very likely.